This integral from Cambridge involves Glasser's master theorem. So basically a special case of this theorem which states that if we have an integral from minus infinity to infinity of f of x minus 1 by x dx, this is actually equal to integral from minus infinity to infinity of f of x dx. This is a special case of Glasser's master theorem, and this will be pretty helpful to solve this problem from Cambridge integration B. Let's see how do we solve this problem. So first of all, we might want to get rid of this expression over here. For that, what you can do is you can just let g equals to y to the power 1 by 2, because if we make this substitution, dg will be 1 by 2 y to the power minus 1 by 2 dy, and then we can have 2 times dg is equals to y to the power minus 1 by 2 times dy. Now with this substitution, the integral now converts to at 0 g equals to 0, at infinity g equals to infinity, and then e to the power minus c. Our y is g square, and then over here g to the power minus 2, and y to the power minus 1 by 2 dy is just 2 times dg. So now we can take 2 outside, and we have integral from 0 to infinity of e to the power minus c. Now we will try to write this expression over here, g square plus 1 by g square in terms of g minus 1 by g, because we want to use this formula. And wait, before that we also need to convert the limits of integral from minus infinity to infinity. For that, what we can simply do is, since this function is even function, we can take this from minus infinity to infinity and remove the 2 over here. Because since this is an even function, the integral in the negative domain will be same as the integral in positive domain. And then using this fact, now we will try to take g square plus 1 by g square as a function of g minus 1 by g, and we can do that simply from the square formula, g minus 1 by g whole square plus 2. So we have g minus 1 by g whole square plus 2, and then dg. Now after this, we can take e to the power minus 2c outside, and we have integral from minus infinity to infinity of e to the power minus c times g minus 1 by g whole square dg. Now using Glasser's master theorem, we know that this integral will just be equal to e to the power minus 2c times integral from minus infinity to infinity of e to the power minus c g square dg. Now this is just a Gaussian integral, and we know that the answer for the Gaussian integral is root pi over this constant over here by c, and that's the answer. So this was a kind of easy integral if you know the Glasser's master theorem, and hope you enjoyed the solution, hope you learned something new. Thanks for watching, and look forward to seeing you in the upcoming videos too.